if, else, while.
Hello everyone. Let me know if the sound is okay. Yes, I hope we're live. I've never streamed, but it tells me I'm live, so yes. Okay, cool. Let me know if it ever gets staticky or quiet. I've never streamed on here, so it's been an experience this afternoon. Cool. We'll get started in like 8-ish minutes. Hello. Wait, am I back? Okay. Sorry, I lost Wi-Fi. This happens like 30 times a day. Hopefully that was the last time. Okay, I probably cut out before, but if you want to follow along, then you can download Git here, and you'll know it works if you just go to like Git Bash or Terminal or something and just go Git, and it won't give you an error. So once you're there, you're good to go if you want to follow along. Oh, we cut off when you had said 8-ish minutes. Okay. Yeah, I think that's everything I said after 8-ish minutes. There's going to be like a component later that you can follow along to if you'd like. You just download Git. So the link is for downloading Git if you don't have it. You don't have to download it now, but you can follow along with some of the commands I'm going to run. And in order to do that, you get Git, and you'll know if it works if you just type in the Git command and it gives you a bunch of choices. So, not necessary, but might be interesting. What exactly is Git for? So I'll explain that. It's basically a way for you to collaborate with your team when you're living really far away. Okay, it looks like it's 7:05 Eastern, so we'll get started. Alright, so for those of you in the US, I'm sure you're somewhat aware of this country's recent spike in insanity. It's unfortunately made this theme a little more relevant than we expected, but anyways, I'm Stephanie. I'm a junior at MIT and I'll be talking about Git. This lecture is probably going to run an hour, a little less than an hour. And this is going to be entirely Git. So if you have questions about strategy or specs or setup, we're trying to get a setup lecture running ASAP, but in the meantime, there is always Discord. All the devs are on it, and a bunch of competitors are there and happy to answer your questions and have you guys answer their questions. Okay, so let me get rid of this slide. Okay. So I'll do like a quick overview more abstractly of what Git is on this mirror of my iPad here. It's basically a version control system, which is a tool that lets you collaborate with other people on projects. Specifically, the tool tracks files for you. So say I have two people, hopefully this is visible, call this Alice and Bob. And they want to collaborate on the same set of files, the same project. But one person lives in Peru and the other one lives in Thailand. So there's like no way to really work together on the same computer. And so this is what Git sets up for them. I'll draw this out and then I'll explain it. Okay, so what Git sets up is something called a working directory. or working area, I guess you could call it, there is a staging area. And this is the remote repository, remote repo. Okay, so this red part, at the very top, is what you're probably most familiar with if you've used GitHub in general. The remote repository is the kind of quote-unquote official version of the project that you'll see on github.com. So if you go to like github.com and you see these files in a repository, this is the remote repository. This is like the official on the cloud, whatever you want to call it. Loving the sidebar, thanks. Hello 6031, yes, good times. Okay, so this is the red part is github.com, and the other two parts are actually local to you. So that's why they're separated. Bob has their own version, Alice has their own version, and this is what you're working on your own computer before you push it up for everybody else to see. So say that some mysterious person gives you one file in your GitHub remote repository. Now, as Alice, you want to get that down from the cloud and work on it on your local computer. So what you do is you run Git Clone, and you clone this entire repository down to your working directory. And your working directory is the local area where you do all of your changes. If you type here, then you're kind of oh, I just closed it. Okay. If you type there, you'll end up with, you'll be working on your remote repository. There it is. Okay, so once you clone, you'll have your own version here, and Bob can clone as well. So they'll run git clone and get their file. So before making any changes, you're going to end up with the exact same version of a file as the file is on github.com. And say Alice types and makes a change. Let's abstract it with a yellow star. So after she makes this change, she can try to push up to the remote repository so all her other collaborators can see. But before she does that, she has to bump up the file to the staging area. And so the staging area is now in this abstract area. And this is where the remote repository grabs from to get the updates to push to github.com. So even if you had other files with like other changes here, if you don't bump them up here, they're not going to be grabbed for the newest commit. And what a commit is like a collection, a packaged set of changes with one message taped over it that you want to send over. Okay, so once you stage the file, you can call Git Push, and that basically pushes every single file in the staging area over to the remote repository, and it's going to get merged in with the remote repository stuff. So since the big difference between Alice's file and the remote version was the yellow star, that gets pushed up to github.com, and then if Bob wants to, Bob can then, the opposite of push, Bob can pull the file down. And what a pull is it's a fetch, so Git fetches the files and then Git merges them with Bob's file. So a pull is a fetch plus a merge. And if all goes well, the file gets merged into Bob's changes, and now Bob has Alice's changes and can look at it, can change it, can delete it, however. And this is the basic workflow of Git. If Bob wants to, I don't know, add a new file, if Bob wants to change this one with some other change represented by the green square, he can. And then he can bump these files up to the staging area with its new changes, and then call Git Push again. And Git Push is going to look at every single file in the staging area again, and then push it up here, and you're going to get a new file and this new change. And then whoever, Carl, Alice, can pull from that again. And that's the basic workflow of Git. Okay, So I think that's it in terms of abstract stuff. Okay, let's go through how you would actually do this with commands. If you want to follow along, go to github.com/battlecode/Git Lock. I'll post this in the chat. Oh, if the file gets merged, does the git pull actually? Oh, it does the, it gets the diffs. You'll be able to see once we run an actual git pull later. But it'll tell you like how many insertions, how many deletions there are. So it operates mostly on diffs. Okay, so once you get here, you can fork this repository. And what fork does is basically give you your own copy of this repository. So after you fork it, it's pretty much separate from the Battlecode version, so you're not pushing versions on top of my pushes or anybody else's pushes. So if you'd like to go ahead and fork the repository. Okay, and then if you're a Mac or Linux user, I think Git will just work on like terminal. For Windows, I like to use Git Bash. I don't know if that's a thing on Mac, but what you want to do is cd into whatever directory you want the project to be in. I'm already there. So I'm going to take the link, and make sure you take the link that has like your username in it, not the Battlecode one. And go Git Clone and paste in the link. Oh, I never deleted mine. Give me a sec to delete it and then reclone. I was practicing and making sure everything was fine. Git Lock, delete. Okay, cool. Works on Mac then. There you go. Okay, so Git Clone basically gives you a local version of this remote repository on github.com. So if you think back to the iPad, basically gets you a working directory copy of remote repository. And they're going to be exactly the same right now because we haven't made any changes. Okay, so I'm going to open this up in Eclipse just because I somewhat tolerate Eclipse. Oh, good now? Okay. I still can't see myself, but I guess other people can see me. Okay. Oh. Wait, am I visible? Can you guys see / here? Rip. Okay. Sorry, I have such bad Wi-Fi. Okay, where was I? Oh, okay, so I just opened this up in Eclipse, and I don't know if you guys heard about cloning, but basically cloning gets you a copy from the remote repository down to the working directory, and you can think of it as getting a copy from like the official up-to-date version. And you only need to clone once at the beginning, and you can keep working on that local copy until you're basically done with the project. Okay, now that I've cloned, I'll cd into the actual project repo. Okay, and One of the most common commands that you'll probably end up using is Git Status. This doesn't actually like do anything, but it gives you a lot of information depending on what state your local and remote repositories are in. So right now, it's telling me that my branch, which is, for now, it's just the version I have locally, is up to date with origin, which is the name of the remote repo. There's nothing to commit because I literally just cloned it. And another really common command that you'll probably use is Git Lock. This gives you a history of all the commits that have happened so far, and it tells you like where those commits are right now. So those are just good to use every once in a while to check in that what reality and to make sure reality and what you're thinking the project should look like match up. Okay, now we'll try to edit a file. Let's give this human an instance variable children. Okay. And by default, there will be no children. If you're confused by any of this syntax, feel free to watch the recording of Elizabeth and Nathan's Intro to Java yesterday. Okay, so now if you go back to, so basically looking at the iPad, this change is basically the yellow star now. In the beginning, it was only in Alice's version. And if I run Git Status now, this is usually a really good time to run Git Status after you change something and you're ready to commit it. You can see that it's a little different. There is a red line, which means that you have something in your working directory. If the text here is red, then that means it's in your working directory. And you can add it to the staging area by going git add. If there's only one file or a specific file you want to add, you can actually type it in. But in this case, I want to add everything, which is just one file. So I'll just say git add everything. And if you run git status now, you'll see that this turned green. And so green files, when you run git status, mean that they're now in the staging area. And this is also a really good time to check. Oh, there's a question. How do we import the git bit to Eclipse? You crashed on that part. Do you mean like the project? To import the project, you can go to File, Open Projects from File System. I go to Directory, and like wherever it is, it was this Git Lock folder, and you click Select Folder, and it should like show up, and you should just be able to click Finish. Yeah, and then it'll show up on the side, and it'll be in like the default package. Cool. Okay. Another thing you can look at, if you've been making a bunch of changes and you don't remember exactly what you've done, you can look at the diffs here. And what you want to do is git diff -- staged, and you can do I want to check the diffs of everything, or I want to check the diffs of just this file. And it'll tell you like what you changed in this file and what you took out and what you put in. Okay, let's go back to Git Status. Within Git Status, if you want to bump this file back down to the working directory, if you decide that this is not something you want to package in your next commit, you can go git restore -- staged, and I'll just restore everything, which is again just one file, and Git Status, you're back to the working directory. And you can also look at diffs here. Oops. Git diff, you just omit the -- stage part. You just go git diff everything, and you can again look at what you've done. Okay, let's go back to the staging area, and now we have one file in the staging area, and if you're ready to package it up with a message and send it on over to your collaborators, you can say git commit. And we want to go -m, which is a flag to tell Git that you want to give this a custom name. And we'll just call it add children attributes. Okay. That webcam is super small. Yeah, it's small because I don't want to cover up any code by accident. I figured the code is more important than my face because you can hear my voice. Okay, commit, and it just tells you some basic info about what you did. If you do git status again, you can see that there is nothing to commit anymore because we just cleared out all our changes and packaged them in a commit. And it sometimes gives you hints. If you want to git push now, you can. Anything else I want to do before I push? Oh, you can. If you do git log, you can see that there is a new commit here. What's the difference between staging area and working directory? Good question. So a working directory is where your files live if you're just changing them. Like if you're just changing all these lines, your files all stay in your working directory. And I'll erase this and try it again. And once you're ready to actually like make change, to package that change up and send it over to your team, then you bump it up to the staging area. So any files, no matter how many changes you've made on them, if you don't bump them up to the staging area, they're not going to be sent over as the next commit. So Git only grabs everything from the staging area. Does that make sense? Hopefully. Okay. Okay, yeah, I was at Git Log, and you can see like the last commit that I made at numchildren attributes. It's only if it says headmaster, that means it's only like in my local version, and origin, which is again the remote repository, it's still it's still not updated. So now you can just type git push and enter. If my Wi-Fi holds up, it should push. And again, this push takes everything in the staging area, which right now is only human.java, and pushes it over to the remote repository. So if I had a buddy here named Bob, they could pull the changes over. And if you try to go to Git Status now, everything is cleared up, so the file disappears from the staging area. And if you try to go to your version of the repository, you'll hopefully see that there is a new commit. You can see like your commit history, and if you click on the newest commit, it'll give you basically the same diff that you saw on terminal. Yeah. All right. Oh, how do we get our ID to recognize? Oh yeah, that might be a Discord or email question. I think a lot of people have been having a lot of different kinds of errors related to that. Okay, so if you ever decide that you actually don't want to have your change moved up to the remote repository, but you've already pushed it, something you should not do is try to actually delete the commit, like erase it from history. Because what that does is, it's possible that your collaborators had already pulled your changes and are like 100 commits ahead of you. And if you delete that commit from history, it's just going to make like a hole in their history as well. And it's more likely to break things. And it's better to just hold on to every single piece of history and every single change you've done, even if it was a mistake. So what you should do instead is call Git Revert Head, and this reverts the most recent commit that you've made. So for me, this opens up Nano and basically lets you update, like give it a custom commit name if you want. I'll just keep it as usual. And to exit Nano, you go Control X and ignore all the error messages. Git bash is weird, I guess. But now, if I check Git Status, it's going to tell me I'm ahead. I'm not behind Origin Master, even though I reverted the changes. I'm ahead because what revert does is it tacks on another commit to the history that basically does the reverse of what I did. So now I have a add numchildren and a reverse add numchildren. And again, I can push this. Okay. And if you go to here, then you can see the new revert commit. And if you look at the diffs, then you can see basically like the exact reverse diff that was done in the previous commit. So this doesn't erase any history and leaves stuff a lot cleaner. WSL2 is better. I agree. My installation's really messed up right now, and I'm missing a bunch of variables, so nothing works on there. Alright, okay, so the next thing I wanted to demo was Git Pull, but because I don't have anyone here to make changes, I'll pretend I'm a new person and let's see. I'm going to make changes at github.com. Oh wait, is this? Wait, I'll make changes on the conversation file. And I'll just be like, hello. Oh yeah, this is one way to make commits and changes. It's not great because you're not going to get it in your local version unless you pull. But now if I still check my conversation.txt, oh, did my Wi-Fi die again? Wait, am I still live? Okay, I think so. If you check your local conversation.txt, it's not going to be there because you need to git pull first. So if you just put in git pull, there's a question earlier about working in diffs or working in actual files. This kind of hints at mostly focusing on diffs because they're a lot smaller. Okay, and now that I've pulled, I can, if I open conversation.txt, I can see this new line here. So that's the workflow simulated by one person, but usually done by many people. Okay. One other thing I wanted to go over was branches. A branch is basically a linear history of a project that's pretty self-contained. So if you think of, let me pull up the iPad thing again, and draw, I'm gonna erase like this chunk here. If you think about this yellow star project as a linear history of a bunch of commits, with these circles being commits and this being like time equals 0, then a branch, this is a branch, and if you have like, these are also branches that can go on different commit journeys and later merge in. But you basically can do a commit, can make a new branch and work on it if, say, you have a new feature that you have in mind, but it might take a while and you're not ready to merge it immediately into the main branch, then you can kind of break off into your own branch as other people are working on the main branch. So what that looks like is you break off here and you can start, you know, adding parts to your feature, and people will be doing stuff to the main branch. And once you get to a point and you think that you're ready to merge, you can just do that, and then there will be like a merge commit, and then you're on your way to working with the rest of your people on the main branch. So they're just kind of like semi-temporary breaks from the main workflow. They're not super necessary. It's not super necessary that you work on multiple branches, especially if your team is really small. But depending on how super organized you want to be or how broken up your features are, it might be nice, or it might be nice in a future project. Okay. let's figure out how to do this on with actual commands. So there's a difference between remote branches and local branches. I'll create a remote branch first, and this only lives on github.com. Since there's a human class, I'll make a pet dog class. I'll call it dog feature. So now, as you can see, the project has 2 branches. And then you can do the same thing locally. If you check git branch, this is basically like the git status of branching. You probably want to check this pretty often to make sure you're on the right branch and you're not like making feature changes on the main branch. And you can go git checkout -b branch name. I'll call it dog feature as well. This is basically an alias for git branch dog feature and then git checkout dog feature, just a one-liner instead. And if you go git branch again, you'll see that we're on dog feature now instead of master. Okay, going back to Eclipse, we're now working on the dog feature branch. So I'm going to create a new class. Call it dog. Okay, what usually happens with the dog? There's a name, page, okay, and I'll give it like a instructor. Again, if this syntax is confusing, feel free to watch yesterday's lecture. This is all described. Okay, this is the change that we want to make to the branch. So now if you go to Git Status, then again, you'll see this dog.java red because it's still in the working directory. And if we want to look at the diffs again, we can git diff. Oh, what happened? Source. Oh, interesting that diffs aren't showing up anymore. But anyways, you can stage the change again. So again, it goes from working directory up to staging area. And if you go git status again, you can see that it's green, it's in the staging area. And you can go git commit, add dog class, class. And we can git push. And instead of just git pushing here, you want to go git push origin dog feature. And this pushes to the dog feature branch of the origin repository. And the origin is the name for the remote repository in this case. Okay, so it went from my local branch to the remote branch of dog feature. And will we go over anything else today, or just it'll just be a Git lecture today? If you have other questions, feel free to ask on Discord or email. Okay, so now if you make sure you're on the dog feature branch and you go to source, there will be a dog file here with all the changes that we added in. But if you go back to Git Lock and you go to the master branch and go to source, then there's not going to be a dog file here because this is the master branch. For now, it's independent from the dog feature branch, and there you won't be able to see what kinds of feature updates there are until you go to that branch. This is just a nice organization tip. You can also pull from branches if you'd like. Let's see. Oh, and there's also, what else did I want to cover today? I think that's almost it. Oh, okay. After you like finish this feature, you might want to like merge it back in. That's like this part here. To do that, you want to git branch, make sure you're on the master branch. If you're not, you want to go git checkout master. This time you don't use the -b because the -b is only for when you're creating a new branch. So git checkout master, if you run git branch again, you can just see that you're on master. And to merge it, you can go git merge dog feature. Yes. Okay, so git merge dog feature basically closed this branch right here. And if you go git status, your branch is ahead of origin by 1 commit. So now you can push. Should work. Go to master. Okay, so now master also has the add dog class commit. If you go to source, there's going to be dog.java here. And at this point, you might not need the dog feature branch anymore. That's often the case. So if you go to view all branches, you can delete the remote one right here. And that's gone. And to do it locally, you can go git branch flag d dog feature. I believe that's it. Okay, yeah, and the branch was deleted. If you go git branch again, there's only going to be master left. So that's a really clean way to organize your features. Oh, and I thought it would be interesting to go over a merge conflict, a really small one. So what a merge conflict is if two people work on the same area of the same file and you try to merge them, Git's going to get confused because Git doesn't have any sentient understanding of what your code does and can't just like fix and pick and choose like which pieces of code to put where if two different people make different changes. It's usually pretty smart if you do other parts of the same file or other files. But let's see, to emulate a merge conflict, I'm going to pretend to be another person on github.com. Let's do this voting on. So instead of vote, let's say somebody changed it to like see you next year. Commit. Okay, so now this is some change that as the local person on this computer, as far as I know, could have been done by Bob and not some other version of me. So if I go git pull, oh shoot, I never made my own change. Ignore that, I'm going to do that again. See you in 4 years. Okay, so Bob made that change, and I come in not knowing that, and I try to say, please cast your vote and be peaceful. And I commit, check, okay, yes, I want to stage everything. I want to commit, oops, change election message. Okay, and now I want to say, before I push everything, I want to make sure that I can pull out everybody else's changes and just see that they work together well. So if I pull, yes, I get a merge conflict. And the reason this merge conflict happens is because I, as the github.com version of myself, try to change this specific line, and then I, as myself locally, try to change this specific line, and GitHub doesn't know what I want. So if you get a merge conflict, you can go to that file and find this weird piece of syntax, which isn't Java, but it's Git's way of telling you what the conflict is. So this line of equal sign is the center of the conflict. And the top part is what you have locally, the head, and the bottom part is, this is the commit hash, I believe, which is just like a unique identifier for the commit. And this is what came in. So Git is just like, I don't know what to do, you go ahead and fix this however you want. So because both of these might be true, I could delete these lines and I could pick both. Or if I wanted, I could, oops, Control Y, go back. I could just pick one of these. However you want to update this, as long as you take out the dashes and the commit hash and the weird syntax, Git's going to be happy. So I think this looks good to me. So what you do here is, let's check Git status again. It's going to tell me I'm in the middle of a merge conflict. And if you decide that you just want to stop doing this merge thing and stop doing this pull thing, you can just go git merge abort. But we actually want to fix this merge conflict. So we're going to stage the file. We're going to commit fix merge conflict. Oops. Okay, and now I can hopefully push. And if I go to github.com, then I'll see this new commit. Yeah, if you look at the diff, oh, merge conflict, that's a merge commit, never mind. But if you go to the human.java, you'll be able to see, like, this is the new, because I chose my version over the github.com version that came in, that got overwritten. I think that was it. Yeah, that's the end. Let me check the chat. Are there other questions? Thanks, Nathan, for covering while I forget that the chat window exists. Yeah, that's pretty much it. I don't think there would be anything much more advanced that you would need for Battlecode specifically. If anyone has questions about this picture or Git or Java in general, I'll stay here for a little bit. But otherwise, I think that was the entire Git lecture that I had planned. Good luck with your robot code, everybody. Oh, yes, Git ignores. Oh, bye, question mark? Yeah, if you'd like to leave, there's not going to be any, like, new material, but I'll answer questions which might result in new material. So somebody asked about git ignore. So git ignore is a special file. If I go ls, I can probably find it. Maybe not. I forgot what the flag is. But if you see a git ignore, it's basically a file that you put file names or folder names in that you don't want recognized by Git, that you want ignored by Git when you try to commit it. So this might be, I guess, like node modules or class path or like project files, things that are specific to you or that you don't want Git to even look at yet. You can add in git ignore, and once you stage git ignore, then those files are going to be like ignored. You don't have to worry about committing your node modules if you don't want to. Does that make sense with git ignore? If you're still online. Usually people put a lot of like boilerplatey directories and stuff in there, so you don't spam other people with your files. Didn't really end up using my conversation file. Kind of. Okay. If there aren't any other questions, I might end the stream. Oh, I don't think I see any more. So, thanks everybody for listening to me ramble for almost an hour. And thanks Nathan for covering questions. Bye everyone.